we want to plot f of x equal to x square minus 1 into e power minus x square. So to plot this, let us look at a couple of interesting points of this equation. So first is what happens to f of x when x tends to plus or minus infinity. So you can see that there is in this function you have this e power minus x square term. So the e power minus x square terms, because irrespective of x tends to plus or minus infinity, this term goes to 0. So the f of x goes to 0 when x tends to plus or minus infinity. So that is the first thing we understand regarding this equation. So next thing is what are the roots of this equation. So to find the roots of this equation, so you have f of x basically equal to x square minus 1 into e power minus x square. So to find the roots of this equation, let us set f of x is equal to 0. So that is x square minus 1 into e power minus x square equal to 0. So this implies that x square minus 1 equal to 0, that is x is equal to plus or minus 1. So this function is 0 when x is equal to plus or minus 1. So third point we would look at is whether there is any maxima or minima for this function. So for that you have to find the first derivative of the function, so of f of x. So let us write down f of x, which is equal to x square minus 1 into e power minus x square. So the derivative of this function is equal to 2x into e power minus x square plus x square minus 1 into e power minus x square into minus 2x, right? So this is the derivative of this function. So if I write down this, I can take e power minus x square outside. So this is equal to e power minus x square 2x plus x square into minus 2x is minus 2x cube. So it is minus 2x cube then minus 1 into minus 2s plus 2x. So this is equal to e power minus x square into 4x minus 2x cube. So basically our interest is to find the maximum or minima. So we have to find out when the first derivative is equal to 0. So let us find out that. So to find out the maxima and minima, we have to find out we have to set the f of f, the first derivative equal to 0 and see at what points there is a maximum or minimum. So this implies my e power minus x square into 4x minus 2x cube equal to 0. So this implies that this is equal to we have to find the roots of this first derivative of the function. So basically this implies that 4x minus 2x cube equal to 0. So this implies 2x minus x cube equal to 0, that is x into 2 minus x square equal to 0. This implies either x is equal to 0 or x is equal to plus or minus root 2. So we have three places, that is x is equal to 0 and x is equal to plus or minus root 2. The function is becoming, the first derivative becomes 0. So either there is maxima 3, minima or maximas, okay, or mix of both. So let us find out at x is equal to 0 to find out whether it is a maxima or minima. Obviously for that you have to find out the second derivative of the function. So what is the second derivative of this function? So let us write down the first derivative first, so that we can follow it easily. So the first derivative is from our earlier equation, it is e power minus x square into 4x minus 2x cube. So so you want to find out f double prime of x. So this is equal to e power minus 2x square into minus 2x into 4x minus 2x cube plus e power minus 2x square into 4 minus 6x cube, x square, 6x square. So this is, I can write it as, I can take down e power minus 2x square as a common factor. So what I am going to get is, so minus 2x into 4x. So that will give you minus 6x square. So minus 6x square. So minus 2x into minus 2x cube. So that will give you plus 4x power 4. From the second term, what are you going to get is one more minus 6x square and plus 4. So this will give you e power minus 2x square into 4x power 4 minus 12x square plus 4. So this is the second derivative you are getting. So now to find out whether it is greater than 0 or less than 0, so that if it is less than 0, it is a maxima. If it is greater than 0, it is a minima. So let's find out the first point, x is equal to 0 point. So for x is equal to 0, so what are you going to get is, this is equal to 4 into e power minus 2x square. So 4 into e power minus 2x square, so obviously it is greater than 0, so it is a minimum. So next is x is equal to plus or minus root 2, because it does not matter plus root 2 or minus root 2 in this the second derivative, because you have the squares. Okay, so I can just put x is equal to plus or minus root 2. I get the second derivative, x is equal to plus or minus root 2 is equal to, so you don't have to write the equal sign, whether it is let us write down the equation first. So this is equal to e power minus 2x square. So x power 4 will be 4. So 16 minus 12 into 2, 24 plus 4. So obviously this is less than 0. So this implies these two are maximum. And this is a x is equal to 0 is a minimum. So if you now we have understood this plot. So x is equal to 0 and x is equal to minus 0. This function goes to 0, and so this is x and this is our f of x, and so there is so the function x square minus 1 into e power minus x square at x is equal to 0, the value is minus 1. So this is minus 1. So here you have minima, and it touches the x-axis because you have found that x is equal to plus or minus 1 are the roots of the equation. So it touches x-axis at plus 1 and minus 1, and there is maxima at minus root 2 and plus root 2. So this is root 2 and this is minus root 2. So the plot is basically, so there is a minima, slope 0 there, so it touches x-axis, then goes to 0. So left hand side, so you can write this one, slope is 0 here, then symmetric basically. Okay, so this is basically the graph. Okay, so it did not come nicely when I plotted it. So okay, you can actually give so slope 0 there. Okay, so this is minus 1. So this is how the plot looks like. So let us look at this plot in a software, how it is plotted. So this what this plot is basically. You can see that there is a maxima. There is a maxima at plus or minus root 2, and it goes to 0 at plus or minus infinity, and there is a minima at x is equal to 0.